black, brown, red, orange, yellow, and green, blue, violet, gray, and white. That is a classified of the resistance of the according to the color coding. We can find it the resistance by the color coding. Color coding give you the a specific number according to the resistance. Is given color coding. Color code for carbon resistor. Since a carbon resistor is a physically quite small, it is a more convenient to use a color code indicating the resistance value than to imprint the numerical value on the cache. In this scheme, there are generally four color band A, B, C. Like that, there is A, B, C. There are four color bands A, B, C, D printed on the body of the register. First, 3A, like that A. So the register. The first three color bands give the value of the resistance, while the fourth bands tell about tolerance in percentage. The table below so according this black, brown, red, orange, yellow, green, blue, violet, gray, white. There is a specific configuration effect of temperature on resistance. If you know that if you increase the temperature, then increase resistance with the temperature given the configuration, the resistance, the temperature. If you increase the temperature, then increase the resistance with the temperature. Ohmic, non-ohmic. Which conductors that follow the Ohm's law are called the ohmic conductors and metal, like that. And non-ohmic conductors, that is non-ohmic conductor which are do not obey Ohm's law, like that I directly proportional to V are called non-ohmic conductors. Vacuum tubes, transistors, and electrolysis, they are non-ohmic conductors. Ohm's law, you know that the Ohm's law, the current flowing through a conductor is directly proportional to the potential difference across the end, provided the physical condition like that temperature, strain do not change. Then I equal to RV. If no, I directly proportional V. But then V directly proportional I, and V it is a constant, then remove by the R, and R is equal to V upon I, and that is a unit of ohms. We can generate the power of an electric appliance. P is equal to Vi, that is a multiplication of the voltage, and it is current. Electric power Q V upon T, that is Q of upon T, Q upon T is called current. That is, a Q is a charge moving through the moving from the conductor, and tie is taken time. That's charge. That means electron. Q equal to N E. E is N equal to number of electron, and E is a electron which that follow in a particular time. That Q upon T is equal to current. Energy. What is energy? The loss of electric potential. Energy is maintaining the current in a circuit, as you called electric energy consumed in the circuit. That is a energy is consumed, uh, voltage and like that, voltage and current V into I, that the taken time in T is called energy. That means which use a particular time. Use of power and energy formulas. Energy formulas, you know that P equal to I square R, and is equal Vi is equal V square upon I, and V square upon R. And you know that W is equal to PT. P is a power, T is a time, W is a work, that means energy. And then after we will discuss about the conductors. Conductor are there are the three types. Conductors are there are the three types, like that, conductors, semiconductors, and insulator. That is material is the three types, so conductors, semiconductors, insulator. Semiconductor, which that the follow we have the free of electrons, and the semiconductors that have the electron, but we added the some impurities for the moving electron. Then but the insulator, they are not they are not doesn't have the free electrons from the material, so that insulator have the negative temperature coefficient. And insulator are used to confine the current to the desired path. Insulator are covalent compounds, that the valence electrons are tightly locked with the neighbor atoms and are not available to support to flow the currents. Electric potential, that the work done by particular charge. There are the two electric bulbs rated for the same voltage have powers of 200 watts and 100 watts. If their resistance are respectively R1 and R2, then P power is equal to 200 watts, and P equal to and 100 watts. In R1 and R2 their resistance, then we can find the R1 and R2. We know that P is equal to Vi, and P is equal to V square upon R. V is the same voltage, and P1 upon P2 is equal to R2 upon R1. there is a P is equal to 100, 200 upon 100, then is equal to R2 upon R1, then R2 is equal to 2R1, that is a resistance R2 equal to 2R1.